Welcome back, guys. We are going to move on to 10.3, day 2. Alright, so I can statement is I can solve radical expressions with extraneous solutions. Alright, and this is something that we've discussed before. Alright, an extraneous solution is the solution that does not satisfy the original equation. Alright, so what this is going to look like now is we're going to find solutions, and there's going to be 2 of them, maybe. Alright, and this time we have to go back, we have to plug them in and make sure that they both work. Alright, so if we take a look at this first example, alright, we have x equals the square root of x plus 6. Alright, so if you remember from the last set of notes, alright, we squared both sides when the radical was by itself, and the radical is by itself. So I'm going to square both sides. Alright, and remember, squares and square roots cancel each other out, so I have x squared equals x plus 6. Alright, now what I want to do is I want to get everything on the same side and have my equation equal to 0. So I'm going to subtract x, and I'm going to subtract 6 from both sides. So x squared minus x minus 6 equals 0. Alright, then, alright, it might look a little familiar because it is a trinomial. So if you do the x method, 2 numbers that multiply to -6 and add to -1, 2 numbers that multiply to 6 that are 1 apart are 3 and 2. And then because this is a -1, alright, the 3 has to be negative. So I have x minus 3 times x minus 2, and that is x plus 2 is equal to 0. Alright, so x minus 3 equals 0, and x plus 2 equals 0. Alright, and then you should be able to tell what each of these solutions is. So x equals 3, and x equals -2. Alright, if you remember, our original equation was x equals the square root of x plus 6. Alright, we just want to think about plugging these back in. So if I plug in 3 back in, 3 equals the square root of 3 plus 6. 3 equals the square root of 9, which is true. So that answer checks out. The other answer, we have -2 equals the square root of -2 plus 6. Alright, we have -2 equals the square root of 4. So we want to think, can we have the square root of 4 be -2? No, we can't. So that means that x equals 3 is our only solution. Okay. Alright, if you see something like number 2, number 2 is actually a lot easier than it seems. So you still want to get the radical by itself first. If you get the radical by itself first, you'll notice that the problem becomes a whole lot simpler. So I'm going to subtract 13 from both sides. So I have the square root of 5 and equals -10. And like I just said, can a square root equal a negative number? Absolutely not. So this one is no solution. And that's it. So if you get the radical by itself first, you can encounter a situation like this where a square root equals a negative number, and then you don't have to do any more work. So that makes it so much easier. Alright, so on the next page, alright, you have 3, all right, for you to try on your own. All right, and we're actually going to walk through the third one together, okay? So the first two should be really, really straightforward and easy because we just did problems just like this. All right, but for C, all right, it's a little bit different. So the radical is by itself, but on the left-hand side, p plus 1. So we're going to do the same thing with squaring them. We're going to square both sides, okay? But this is really p plus 1 times p plus 1. And that's going to equal, I'm just going to already cancel out the square root in the square, 7p plus 15. All right, so p times p is p squared. P times 1 is 1p. 1 times p is 1p, so that gives us 2p. And then 1 times 1 is 1. So I have p squared plus 2p plus 1. All right? So now I want to get everything on the same side of the equation. So I'm going to do just that. So I'm going to subtract 7p. And I'm going to subtract 15. So I have p squared, all right, minus 5p, all right, and then minus 14 equals 0. All right, so I have a nice trinomial, which is factorable. All right, and I'm going to use that, all right, with our x method. So two numbers that multiply to negative 14 and add to negative 5. So if you think about it, there's only two ways you can multiply to 14. 1 and 14 and 2 and 7. 2 and 7 are 5 apart, so I have 2 and I have 7. Because they have to add to negative 5, that means my 7 has to be negative. So then I have p plus 2 and then p plus 7. All right, all those multiplied together equal 0. All right, and then I just set p plus 2 equal to 0, and p plus, that should be minus 2, my bad. P minus 2 equals 0, and p plus 7 equals 0. So then this equation tells us that p has to equal 2, and then this equation, p has to equal negative 7. All right, and I'm going to plug both of these answers back into the left-hand side. All right, because we know that if we equal a negative number, then it won't work. So I'm going to do 2 plus 1 equals 3, so that is positive, so that's probably going to work. All right, negative 7, so negative 7 plus 1 equals negative 6. All right, a square root cannot equal a negative number, so that one is out of the running. So p has to equal 2, and that is the only solution. All right, so all these problems will only have one solution. You might find two, but only one of them will work. All right, and time for the last problem. All right, so the period p in seconds of a pendulum is given by the function p equals 2 pi times the square root of L over 32, where L is the length of the pendulum in feet. All right, a certain pendulum has a period of 4 seconds. Is this pendulum twice as long as a pendulum with a period of 2 seconds? Explain or reason. All right, so what we're going to do is we're going to find the length of each, all right, pendulum. All right, so we're going to make an equation for each of these pendulums that we're given. We're given a period of 4 and a period of 2. So 4 equals, all right, 2 pi times the square root of L over 32, and we have 2 equals 2 pi times the square root of L over 32. All right, so like I said before, we want to get rid of anything that's attached to the square root, get the square root by itself. So because we're multiplying, all right, in both equations, I'm going to divide both sides by either 2 pi in the right equation. I'm actually going to divide by 2 pi in both equations. All right, and we can actually simplify both equations. So 4 divided by 2 is 2, so I have 2 over pi equals the square root of L over 32. And then over here, 2 divided by 2 is 1. So I have 1 over pi equals the square root of L over 32. All right, like I said before, we have our square root by itself, and now we're just going to try to solve for L. So because we have a square root by itself, we're going to square both sides of both equations. All right, so 2 squared is 4, and I'm just going to write pi squared is pi squared, and that's going to equal L over 32. All right, 1 squared is 1 over pi squared equals the L over 32. All right, so now what we're going to do is we're just going to multiply by 32 on both sides to get rid of that denominator of 32. So 32 times 4 is 128. So I have 128 over pi squared equals L, and that's for the period of 4 seconds. And then I have 32 over pi squared equals L on the right. So if you notice, all right, we actually quadrupled going from 32 to 128. So we're going to say that no. All right, we're going to say it's 4 times as long. All right, and this is all the work that you would need to show. Okay, so hopefully, all right, you don't have too many questions. All right, but if you do, let me know. Shoot me an email. Hop on the Zoom. If not, I will see you in the next one.